right, so for this particular problem, we need to talk about the concavity and see where this function is concave down. To do that, I need to get to the second derivative. So y prime, to start things out using power rule, would be equal to 12x cubed minus 48x squared plus 48, try to squeeze this in here, x. All right, that means y double prime, our second derivative, I don't know why that's not coming up there, there you go, is 36x squared minus 96x plus 48. That can be factored easily enough. So y double prime is going to be equal to, let's factor out a 12 here. So I get 12 times 3x squared minus 8x plus 4, which, to simplify it one more time, is going to give us 12 times, how about 3x and x, and how is negative 2 and negative 2. So factored here, I have two possible points of inflection, specifically at x equals 2 and x equals what, 2/3. As that's what's going to make my two factors equal to 0, thus being potential points of inflection. The next thing I really need to do is look for when this is concave down, right? Bringing in our calculus sunshine, that's really when this thing's going to be negative. The second derivative, we want to be less than 0. So in order to do this, I can set up a little bit of a sign chart. So I'm going to erase and give us some space here. My sign chart is really going to be using the second derivative, and it's going to set up around our possible points of inflection at x equals 2/3 and x equals 2. So finish up and getting some space here. All right. So my sign chart again is going to look something like this. Nice long line. I have a point at 2/3 and a point at 2. I know that my second derivative is 0 here and here, and that's f double prime. So let's go ahead and test some points on my second derivative. If I put something into my factored form of my second derivative that's bigger than 2, I'm going to get a positive times a positive times a positive, meaning we're positive here. So that's not what I'm looking for. If I put something in here that's between 2/3 and 3, such as 1, between 2/3 and 2, such as 1, I'm going to get a positive times a negative. So in there, that interval is working for us. So right now, between 2/3 and 2, we know is going to be negative. That looks like it's the only interval here that really works in terms of answers. We can get rid of A and B because we have nothing to do with 0. Negative 2 doesn't work for us. That wasn't even a possible point of inflection. And D doesn't work because we know when x is greater than 2, this didn't work for us. This was concave up there. So again, when our second derivative is negative, we know our function to be concave down. So the correct answer here is E.